Hi, Chris from ECUMaster USA Support. Today I'd like to cover VVT PIDs and just zeroing out the VVT cam. This will be for the ECUMaster EMU Black V3 software. Start out by explaining a VVT solenoid, how it works. It's a spool valve. It basically, you're controlling three positions. The first position is the maximum solenoid duty cycle that you're setting that allows the piston to move forward and the oil flow to fill the cam phaser to push the cam one direction to advance the cam. You have a middle position, which is a steady state duty cycle that you'll set, and that locks in that oil volume to try to hold that oil volume to hold the cam angle target. Then you have a minimum duty cycle, which moves the spool valve this direction so that the cam can go back to its resting position in the cam phaser, which is full retard. First, let's go over where the VVT settings are. In the left-hand parameters panel, expand VVT, parameters, and PID. There's the parameter window and the PID window here. Another thing we'd like to go ahead and set up is click Other, open PID monitor, and verify or set PID monitor to VVT cam 1 or any other cam that you're working with. This will log PID terms so that you can see what is happening in the graph log. Once you select that, make permanent, then in the graph log you can right click any of these parameters and set log channel and choose VVT cam angle, cam solenoid duty cycle, cam 1 angle target, monitored P term, monitored I term, and monitored D term. So right now we are zeroed out on PIDs, and we will start with the cam angle. You need to zero out the cam angle if you haven't already. If you look at cam angle and you have minimum RPM set maximum so the solenoid duty cycle is not applied, make sure that cam solenoid duty cycle shows 2%, which is minimum, it's not active. And then make adjustments to cam 1 parameters, cam offset. This will zero out this value. If you look in the parameters panel down here, you'll see VVT cam 1 angle. In the parameters, you see cam offset. So it's 20 advanced is what it shows. So remove 20 from that, and you'll see the cam angle goes to 0. It will float between negative 0.5 to 0.5 positive. It doesn't matter, it's zeroed. It's as close as you can get. If you don't know the frequency of the solenoid, you can start from 100, 250, 300. Toyota is normally 300. This Mazda with the 2-liter engine is roughly 250. But you can start out with 100 and it will normally work. You can experiment with the frequency or hook up an oscilloscope with the stock ECU to see at what frequency the stock ECU is controlling the solenoid. In V3 firmware 3.062, they provide an option to override the duty cycle and override the target. If you don't have this option to override the target, you can update to the newest software and firmware or you can simply go to cam 1 angle and change all of these to 20, and that will give you a 20 target. We'll work off of the override target for now. Now that we have this, the cam angle zeroed, let's decrease the minimum RPM to 800 to activate it. So what we're going to do is we have steady state position. This is where we start, and we'll override the duty cycle, and we'll set a target of 20 degrees. So currently you can see in the graph log you have a target of 20 degrees, but the cam angle is still 0. It also shows here in the tune display. VVT valve requires oil pressure, so you have to increase the RPMs to 2,000 to 3,000 to make these adjustments. Normally at idle, there's not enough oil pressure to hold the cam target, and idle is normally 0 degrees either way, so you can always target 0 degrees at idle. So now that we're at 2,000 RPM, we can start to increase the duty cycle slightly until cam angle 1 starts to move. Okay, there we go. So cam angle started climbing, and if at 41%, if I drop it to 40%, you'll see cam angle start to decline. We'll call that good. We'll call our steady state 41%. Let's release the override duty cycle. We'll leave the cam target enabled at 20. You can see if I increase RPM, it tends to increase cam angle. If you don't have PID set, because it's just filling up with oil, there's more oil pressure at that point. So we'll hold it somewhere around 2,500 RPM. We'll add 1 on the gain. And we'll pause here for a second. You can see what happens is it was high. It was 30 degrees when we targeted 20. When we increased the proportional gain, it took control of the solenoid and it dropped it down to 20. You can see monitored P term here. It's at 0 until I changed it to 1%. It started affecting the duty cycle to bring down the duty cycle and meet it. That's what gain does. Gain tries to meet your target, move faster or slower to meet your target. Let's show you what too much gain looks like. If you're still looking at monitored P term, and if I increase this gain to 2, you will see an oscillation start to occur. When that oscillation occurs, you can also see what it's doing to the duty cycle and what it's doing to the cam angle. This is too much gain, so start backing down. You can put it back on 1.5. You can try. And 1.5 still seems to be oscillating quite a bit. So we liked 1. If you put it back on 1, it somewhat smooths out. There's a slight oscillation. And if that's the case, you can even go 0.8 to see if that smooths out and still meet your target. This is close. We'll leave it at 1 for now. And it's holding it pretty good at between 19 and 20 degrees, depending on how much oil pressure that it has. So what we'll do is release the override target. Cam angle target is down to 0 per the cam 1 angle table. Now we're going to increase throttle to see if cam angle can meet cam target. What you get is a slight overshoot. Target was 23, and a little bit after, it shot all the way up to 27. And then slowly came back down. You can see the delay there. We already know that too much gain starts to oscillate, and we don't want this oscillation. So now we can change integral gain. We can make big settings first to see what happens. Let's go to 1, and you can see I terms start to increase slowly. Give it a rev, see what it looks like. It's a little bit latent. We can see if we can correct that. Let's increase the solenoid max, see if that helps with increasing the cam target. It does not. It has a latency there, which may or may not be able to be helped. You have some options here. You have some other things that you need to set. One is minimum solenoid duty cycle and max solenoid duty cycle. Max solenoid duty cycle and minimum may affect how slow that responds. You're not going to get cam target perfect. This specific engine was a little bit tedious to tune, so it does have a little bit of latency. This is something that you're going to have to work with, and it does take time. I'm only covering the basics of PID and setting the duty cycle min max in steady state and frequency. Derivative puts the brakes on the angle if it goes over. If it's too much gain, derivative will kind of try to stop it. Too much derivative will actually start another oscillation in the output. I'll show you what I mean. If we change derivative to 1 and we hold cam angle, you can see derivative or D term is fluctuating heavily, which causes the duty cycle to fluctuate heavy, which causes cam angle to fluctuate. So we can reduce this. Let's try 0.05. You can see derivative is actually trying to slightly stop. It's not as erratic anymore. It's under control. This might be enough to do what you need to do, and as you can see, there's 30 degrees target, 31, 32. There's a little bit more angle than target. You can try to decrease integral. Looks like derivative is still in the way a little bit. We can reduce that to 0.02. See if that just slightly controls it. That looks good. And you can see that it's pretty much keeping target. You got slight overshoots, but this will take time to change the settings, the PIDs. But now you can see you have P term that you can watch. If it starts oscillating, reduce it. Reduce the P term to smooth it back out. And this is true for all of it. If integral gain is too high, it will start oscillating. If derivative is too high, it will start oscillating. Just play with each one of them to get your cam target better, and watch your P term as well to make sure that it's not maxing out on your output max and your integral term limit max. You can play with all these settings. If you need any help with what some of that means, you can click the question mark in the specific feature window, and V3 does have help to show you the descriptions of each field that can help you. I hope that covers enough for you to get started, and happy tuning.